And Brian, sticking on the theme of process, how does your biological process work for desulfurization?
Yeah, so let's take a breakdown of the process. So to take a step back, we utilize what's called a trickling bed reactor. I have a picture shown here on the slide, which illustrates a project we have in Seaboard Energy in Texas. And a trickling bed reactor is essentially the simplest form of a reactor you can have. It's a packed bed reactor, which in plastic media that I told provides the surface for the Theobacillus. It's a very biological process. It's 100% biological. There's no chemical added. This trickling filter utilizes the recirculation of the sump material, so where we also have the sulfate, but also where we add some nutrients and some water to keep providing the correct temperature, as well as nutrient to all the Theobacillus. Then oxygen is introduced along with the sulfur-rich gas, and hereby the Theobacillus has what they need to perform their metabolism, and we get to enjoy a desulfurized gas. We do have a short video to illustrate how a reactor would work in real scale.
In the top of the tank, biogas and air is injected and slowly flows down the packing material with hungry bacteria. When the biogas reaches the bottom of the tank, more than 99% of the H2S is removed.
Yeah, so as we see on the video, by providing the right parameters, we can remove more than 99% of the hydrogen sulfide. It does require that we provide the correct amount of temperature, which is around 95 degrees, as well as we will also need to put in some nutrients for the Theobacillus. Besides this, we have the desulfurized gas that comes out as a product, and what we have now is a very low oxygen product, which can comply with gas grid regulations, so it's ready for gas grid injection. It's a self-regulating process. We have optimized and developed a lot on this process, which means that we have also developed a system which is capable of regulating alongside the production site it's integrated into. So small variation within the design specs is expected, and our system can regulate on its own. The products from the desulfurization is elementary sulfur, as I mentioned, which will be fixed on the packing media, and that does require some cleaning eventually of the reactor. The cleaning process we have simplified a lot by our patented QSR system, which is a contraction of quick sludge removal, which is essentially where we fill up the reactor with water and we tumble it around to dissolve and remove the sulfur from the packing media, and then we can drain it out, and we there have a clean reactor, as well as we have a sulfur-rich process water, which has a high nutrient value and you can use on the fields as fertilizer.